Hello everyone. Now we shall go to the next problem in a projection of solid series. So we have here a square pyramid of 35 mm sides of base and 60 mm axis length rests on HP on one of its corners of the base. Draw the projections of the pyramid when the axis of the pyramid is inclined to HP at 40 degrees and to VP at 30 degrees. So let us look at the criteria which we are supposed to satisfy. The first criteria is the shape, which is a square pyramid. Second criteria is dimensions, that is 35 mm sides of base and 60 mm axis length. Third criteria is it is resting on HP. Fourth criteria is resting on one of its corners of the base on HP. And the fifth criteria is the axis of the pyramid is inclined to HP at 40 degrees and the same axis is inclined to VP at 30 degrees. Right? So let us solve the problem. The first step is to draw the XY line. So I have X, Y, VP and HP. Right? The next step is to draw the square pyramid, but in corner condition. That is, we are drawing the square pyramid of 30 mm sides of base and 60 mm axis length. So what I will do is I shall draw a particular vertical line. So since you people have grids, you can make use of one of the vertical edges. So I'll draw a vertical line over here, just for your understanding, and I shall take a point here, and from that point I'll draw two 45-degree lines. The two 45-degree lines being one 45-degree line here and the other 45-degree line over here. Right? So from these 2 points I shall draw the edges. Of 35 mm sides of base, right? So I shall cut two arcs, one over here and one over here, and again from the same points I shall draw two arcs over here and over here. So I shall get the four corners of the square pyramid. And as I told you, the inclined edges from the axis point, that is from the vertex, will be visible to us in the top view. So I shall draw the diagonals also in proper visible lines. So I have my points. So I'll call this point as A, B, C and D. So this angle initially I had taken 45 degrees. You need not have to mention it, but looking at it, so for naming purpose, for your understanding purpose, I have written over there. You need not have to draw it. Okay. Then I have my point O bracket O1. Right. So let us give the dimensions for this. So since we do not have a vertical line or a horizontal line, we have to take one of the inclined lines. So this happens to be square of 35 mm. So from here on, let us draw the projection lines and get the front view for this. Again in here, I'll be able to see only a triangle in the front view. So since the axis length happens to be 60 mm, from here I shall measure 60 mm and draw and moreover I shall take 60 mm, instead of drawing the axis line directly, I will draw the visible line, because the edge inclined edge of O to B will be in front of the axis line. The axis line will be hidden behind that visible line. So I'll be drawing only the visible line in the front view, right? Although my axis line is very much present, but I will not be able to see it. So this point becomes my B bracket O1 dash, B dash bracket O1 dash bracket D dash. This point here is my C dash, this point here is my A dash, and this here is my O dash, right? I'll draw the dimensioning line for this of 60 mm length. So everything with respect to the first position front view is completed. Okay, so we have drawn a square pyramid of dimensions 35 mm and axis length 60 mm and resting on one of its resting on HP. And we have ensured that in the second position it is going to be resting on one of its corners of the base. So we have drawn it in corner condition. So either I can rest it in such a way that it is going to rest on C dash, or I can rest it in such a way that it is going to rest on A dash. That is, if I rotate it clockwise, if my point O to O1 is rotated clockwise, it will end up resting on C dash. If I rotate it anti-clockwise, it will end up resting on A dash. So however, I will draw it by rotating into the clockwise direction. So I will take an appropriate point C dash here. Next, again, see what is mentioned is the axis of the pyramid is inclined to HP at 40 degrees. So I told you over here the angle theta is equals to 90 minus the angle provided, that is 40, which is 50 degrees. So I will be drawing the base inclined in the opposite direction at an angle of 50 degrees. So in the opposite direction, inclined at an angle of 50 degrees. So I am drawing a line. So this angle happens to be 50 degrees, right? Now next I'll measure this length from C dash to A dash. C dash to A dash I shall measure and I'll cut the arc. Next, from C dash to O dash I'll measure again. And from A dash to O dash also I shall measure, and I'll get my point O dash over here. Next, I'll join all these points now. O dash to C dash, O dash to this one over here is my A dash, O dash to A dash, and C dash to A dash. Now again I'll measure half the distance, that is C dash to B dash bracket O1 dash bracket D dash. I'll measure this distance and I shall also cut the arc. And I'll draw the visible line. So this happens to be my B dash bracket O1 dash bracket D dash. When I extrapolate this line backwards, automatically this line becomes 40 degrees. That is why I'm just, since this is 90. So again, so 90 minus 40 will give me 50 degrees. So I start off with 50. So automatically this becomes 40 degrees, right? Next, let us draw the projection lines for each of these points now. So from C dash, I'll draw one projection line. From B dash bracket O1 dash bracket D dash, I shall draw one more projection line. And from A dash also, I'll draw one more projection line. And from O dash, I'll draw another projection line, right? And from here, from each of these points, I'll draw the projection line. So from D, A and C have one common projection line all the way up to the point O. And here, So let us locate the point. So I have my point A over here, my point B, C and D. Then I have my point O. To join all these points, again follow the rules. Draw the outermost edges with visible lines. O to D, A to D, next, identify the point closest to the XY line or touching the XY line. In this case, it is C dash. So any line coming out of C dash will be a hidden line. The lines coming out other than the outer edges. So C to D, C to B, and C to O. All these three lines are not form part of the outer edge. So C to D, then C to B, and finally C to O. Then the fourth rule is all the other remaining lines are visible lines, that is A to O. So if you see here, C to O, there was a hidden line, but I have a visible line in front on top of the C to O, so the preference is given to the visible line, right? And this point here happens to be my O1. Finally, again, this is another beta angle problem. So the axis makes an angle of 30 degrees to VP. So what we will do, we shall draw two projection lines. Draw a parallel line to the XY line. Okay. From this point, I shall measure 30 degrees. So at this time, I will take it the other side. So here, I'll draw 30 degrees, 30 degree line. So this angle happens to be 30 degrees. From the first position, front view, measure the total axis length, which is 60 mm. From this point again, I shall cut the arc. Through this point, I will draw a line which is parallel to the reference line or my XY line. All these three lines are parallel to each other, right? Now coming to the second position top view, O2, O1, I'll measure. Keeping it here, I shall cut the arc. I'll get my point O1. So from O1 to this, I'll draw the line. If I were to draw this line all the way backwards, it will tell me the angle of inclination to the reference line. It is crossed the border line. I'll just draw it across. So my beta angle, this happens to be my beta angle. This is my Y. So my beta angle is 40 degrees. Okay. My beta angle is 40 degrees. Now what I will be doing is, I will be recreating the second position top view, the third position top view. So how I will go about doing is, first I will measure from O1 to A. O1 to A I shall measure. I shall keep it here and I will cut the arc. I will get my point A. Next, O to D, I shall cut the arc on both sides. O to D and O to B will remain the same. Next, from A to D, A to D and A to B are the same length. So from A, I'll cut the arc again. And from O1 to C, I shall measure and cut the arc. I'll get the point C. So I have my point A over here, B over here, C and D, and this is my point O. So Basically, we are recreating the second position top view in the third position top view. And finally, this becomes visible line. Now, let us draw the projection lines and get the front view for this. Okay. So, from each of the points, I will be drawing projection lines from D, A, B and C, and including my point O. So again, draw the projection lines from here also. This becomes my point O dash, from A dash, from B dash bracket D dash, and from C dash. So locate all the points now. So A and A happen to meet here. So this is my A dash. B and B happen to meet here. So this is my B dash. C and C happen to meet here. So this is my C dash. D and D happen to meet here. So this is my D dash. So join all these points with proper visible lines. So apply the rules again. So O dash to C dash. If you can observe, my point B dash is on the inside, so it doesn't form part of the outer edges. O dash to A dash. A dash to D dash. And D dash to C dash. Now, when we are identifying the point closest to the XY line, okay, especially in case of pyramids, do not assume the vertex O dash. Other than the vertex, identify the point closest to the XY line. This is applicable only in case of pyramids, not in case of prisms. Okay, only in case of pyramids. If you have a point O closer to the XY line other than the other points, please do not take the point O. Okay, in the previous problem, the point O was not closer, so we directly solved the problem. But here the point O happens to be closer to the XY line, so please do not take the point O. But other than the point O, identify the point closer to the XY line. So which point is that? That point happens to be my point D. So any line coming out of D or D dash will be hidden line unless it is an outer edge. So the lines coming out of D dash is D dash to A dash, D dash to C dash, and D dash to O dash. So D dash to A dash and D dash to C dash form the part of the outer edge, so they cannot be hidden line. But D dash to O dash, it is not forming part of the outer edge according to our figure, so automatically becomes a hidden line, right? And the fourth rule is all the other remaining lines are visible lines. So B dash to A dash, it is a visible line. B dash to C dash is a visible line, and B dash to O dash is also a visible line. And from here, let us draw the projection line for the axis point O1 also. So I have my point O1 over here. So I have my axis line. So we have our solution. Thank you for your time.